George is popular.
That's my team. Okay, so is the sound clear? Is it good enough? Okay, let's start. Welcome everybody. My name is George Sotiropoulos and I'm a member of the mobile team in XM. And today I'm going to talk about snapshot testing. But before going into snapshot testing, let's take a step back and let me give you a quick overview of all the software verification methods that we use in our team in order to verify that the code we write actually meets the expected requirements. Static verification is actually divided into two categories. The first one is static, okay, and where you actually check if the requirements are met by just inspecting the code and not running it. And the second category is dynamic, where you actually run the code and dynamically inspect its behavior. For static verification, we take advantage of the type system and the static guarantees that it can provide to us. We do static analysis, and we also do extensive code review. And for dynamic verification, we write, of course, unit tests, snapshot tests, characterization tests, integration tests, UI functional tests, and of course, we also do manual testing. As you can see, snapshot test is just one of the methodologies that we use to test our software, and it's complementary to all the others. But what exactly is snapshot testing? Snapshot testing is just a form of unit test. In the unit test, you have a function, and given an input, you directly assert the output. But in the equivalent snapshot test would look something like that. And the main difference, as you can see, is that there is no explicit expected output. But then how does it work? Basically, you can run the snapshot test into two modes. When you run it in record mode, a snapshot of the output is produced, and it is saved as an artifact on the disk. And when you run it on verify mode, again, a snapshot of the output is produced. It looks for the disk on the disk for the previously saved reference snapshot. It compares the two snapshots, and if they differ, the test will fail with a nice error message. In the mobile community, the most popular form of snapshot testing is actually screenshot testing, where the snapshot is just an image of a UI, and the UI can be the screen of the application or just a single view. When you run your screenshot test in record mode, a reference image is produced and saved to the disk. And every time you run it on verify mode, the newly generated image is compared to the previously saved reference image. And if they differ, the test will fail and the diff will look like that. Sorry. It's the same concept as before, but instead of having text as the generated output, we now have an image, and instead of using text comparison, we now apply pixel by pixel comparison. And there is a more general underlying concept here that says, if you can express your output in a format that can be saved to the disk and that you can compare and produce out of it, then you can apply snapshot testing. But why bother? Why doing that? I would argue that by just adding screenshot testing into the project, you would have actually gained quite a lot. The most important thing is that it provides far more coverage than a unit test normally allows. If you wanted to unit test the UI, then you would have to write multiple assertions on the fonts, the sizes, the colors. But with a snapshot test, you just produce an image. It's also a very fast way to see how your view looks like while developing. You don't have to fire up the simulator or open the browser and navigate to the specific screen just to see how the view that you're currently developing looks like. You just look at the produced screenshot. And it's also a way to make sure that everything still looks OK and avoid UI regression errors. OK, these are some benefits, but we didn't stop there. We wanted to maximize the benefits we can get from snapshot testing, from screenshot testing. So basically, we try to to use snapshot testing also to check how our view looks like in multiple states. This view, for example, taken from our application, informs the user when the market is open for trading during the day. And if we just mock the data of the view, we could quite easily see how the view looks like when the market is closed, or where there are more than one open intervals within the day. So we have checked some extreme cases. If you wanted to see how the view looks like in multiple languages, quite easy, you can also do that. Just generate a screenshot for each language. But if you want to avoid generating a lot of screenshots, you could use a pseudo-locale to simulate strings with increased length and quite easily check if larger text actually stress your UI. If you wanted to test how that view looks like in larger devices or if something breaks in smaller devices, no problem. You can do that as well. Just generate another image, another test case. And if your application, like ours, also supports a dark theme, guess what? No problem as well. Combining all the above, you would have ended up with something like this, and you would have tested probably a lot of cases that otherwise you would have never bothered to manually recreate and test. And the nice side effect of adopting screenshot testing is that it actually changed our workflow when developing the UI. Because now you have a very fast way to see how the view that you're currently developing looks like. You can and should actually develop the view independently. You don't have to wait for the container to be implemented first and then start developing the view. Thus, the pull request becomes quite concise. It only contains the code about the view itself, along with the screenshots that enable you to see how the view looks like. And actually, the screenshots provide a visual dimension to the pull request, reducing the cognitive effort for the reviewer when checking the pull request. You no longer have to imagine how the UI code will look like. You actually see it. And as we said, you can test multiple configurations, devices, languages, themes, all at once, and be done with it early in the development phase. Instead of capturing images, just to check if the UI did not break unexpectedly, you could also capture text. All you have to do is find a way to produce a textual representation of your views. And actually, this is what a test failure diff would look like in Jest. Jest is a very popular testing framework in JavaScript. And by using the textual representation in snapshot testing, you actually have the added benefit that you can also test elements that are non-visible, like this hyperlink. But snapshot tests are not only used for testing the UI. It turns out they're also great for testing complex data structures that have lots of properties. If you could, for example, produce a textual representation of a URL request, then with just one single assertion, you could test all properties all at once. For example, the body, the method, the URL, everything. You don't have to write and maintain multiple assertions. And you can choose how this textual representation would look like. I mean, you can, for example, serialize your URL request as CURL commands. You are the one that chooses it. And if your complex data structures can be easily converted to JSON, like in this example, then, without any effort, you can just produce a JSON textual representation. And this is actually how a JSON snapshot would look like. In this case, again, using one assertion is more than enough to check all properties. And in this specific example, using a certain line snapshot does not save the artifact on the disk, but directly places the snapshot inside the test. If you write programs or libraries that produce files or output with a complex data format, then snapshot testing is also very, very helpful. For example, if you write a program that generates PDF files, and you would want to test that, then you would end up in the unit test world writing multiple assertions because the internal data format of the PDF is actually very, very complex. But instead, you could use snapshot testing. You could generate an image out of the produced PDF and use that to test everything all at once. The same is true if your program produces XML, HTML, or even code. And in the latter case, you can actually use the compiler as well to further validate the correctness of the generated snapshots. Snapshot tests are essentially change detectors, and it is up to the person reviewing the changes to check if the changes are desirable or undesirable. And because they are change detectors, they are also ideal when you use external systems that you do not control. For example, your program might consume an external API. Again, in the unit test world, if you wanted to test that, you would end up writing multiple assertions for all the properties of the API response. But with snapshot test, you can just write one assertion and test all properties at once. And it's also interesting to note that in unit test, you could never be able to catch if an extra property was added in the API response. It's also ideal when your output depends on external libraries that you want to update from time to time. For example, in this example, we have a library that is currently on version 1, and it is used by our program to generate some output. Now, when we want to update the library to version 2, we want to make sure that the output remained the same and that the library update did not play any role. I mean, this is quite important because we are all afraid of when updating our dependencies if something changed. With snapshot test, you can actually track that. Finally, snapshot tests are great because you can also use them when you write characterization tests. And that's because in characterization tests, you're mainly interested when the output has changed and less about whether the output is correct. One would write a characterization test when he wants to check, to refactor actually untested code. So what he basically wants to do is to lock the system to its current behavior and then track if the refactor he did produced any changes. So you don't care about if the behavior is good, but you want a way to be able to track if your refactor produced any changes. And because snapshot tests allow you, without any effort, to test multiple properties with a single assertion, that makes it super, super fast to lock the behavior when you write characterization tests. But of course, there are some pitfalls about snapshot tests that we should all be aware of. Being effortless to update, it's also easier to accept new snapshots that might have problems. So snapshots themselves should be part of the code review as well. The context of what you test is actually lost because the body no longer contains any information on what's been asserted. If you remember from the first slide, we said that the explicit asserted output is missing. So you have to write very rigid test descriptions in order to understand what you're really testing. And sometimes it might also lead to fragile tests. For example, your program might be interested in some properties of the expected output, but if any property changes, then the test will fail, even for properties that you don't really care. That's it. If you want to know more about how the mobile team uses screenshot testing to test the UI, you can find the blog post in our Medium channel. Just search for screenshot testing at XM Global. Here are some tools that allow you to do either screenshot testing or snapshot testing for Swift, Kotlin, and JavaScript. For you people out there, I guess you're already familiar with Jest. Use snapshot testing, play with it. It's very interesting. And remember, it's only complementary to all the other methods that you use to test your software. The presentation will be available on Speaker Desk. Just search for the title of the presentation. Here we have, in the article, in the previous slide, you will find some GitHub projects that show how to set up screenshot testing in Android and iOS, and some nice articles that you can be informed more about the subject. And in XM, we're actually a big company. We're a market lead in Forex trading. We have offices in Cyprus and in Athens, and there are currently a lot of positions open. So if you're interested, please send an email to the HR or just visit our careers page. And I guess that's that. And you all know, probably a lot of you already know the competition that is running. I think today it's ended, but tomorrow you can join deadbull.xm.com and win the prizes. Okay, thank you guys. If you have,